All right, so we are going to graph this A function on the first grid. So take whatever your first color is, because we're going to color code all four of them. And we're going to look at the transformation. So this is cube root. It's going to be like a sideways wiggly thing. How did it get transformed? Like using words like up, down, left, right. Right one, good. Down three. That's where your center is. So you're going to go right one, down three, put a point. And then we want to pick some other numbers around that. So let me make a table. All right, so we're centered there at one. If we try to plug in two, let me see if that'll work. 2 minus 1 would be 1. 1 times 4 is 4. Cube root of 4 without a calculator. I cannot do that. Okay, so 2 didn't work. Let's try 3. I think 3 is going to work. 3 minus 1 would be 2. 2 times 4 is 8. Cube root of 8 we can do. What's your cube root of 8? Good. 2 minus 3 is negative 1. So we get 3, negative 1. And then same thing in the other direction. Like 0 is not going to work out, but if we go one number further, so like if we do negative 1, then it's going to turn out okay. Negative 1 minus 1 would be negative 2 times 4 would be negative 8. Cube root of negative 8. Negative 2 minus 3, negative 5. So negative 1, negative 5. And again, when you do these, the cubic and the cube root ones, it's going to look linear. You just need to remember that it's not. So when you connect these, make it be like a sideways wiggly thing and make it go all the way to the edges of the grid, okay? And this is graph A. At the bottom, you want to put an A in the left corner and the right corner, and then also right below the axis. So the left corner, the right, you'll see why. We're going to cut it all apart. All right, but you want an A in all of those. So grab another color, switch with someone near you so that you have a different color. And if you look at like not having enough, like if you figure out all right, so now we're going to look at graph B. Are y'all good? All right, this one's exponential, so it's going to have a horizontal asymptote. It moved what direction? Up 1. So you're going to go up 1 and dot that in. Again, make it go like all the way to the edges. And again, I'm just going to make a little table of values. So you want to find the center. Did this shift left or right? It went right 2. So we want to start with 2. 2 is where the center is. So we're going to try and plug in 2. 2 minus 2 is 0. Anything to the 0 power, good. We've got that. Nice. And then 1 plus 1, 2. All right. So then let's plug in 3 and 4. Like do some numbers near 2. So if you plug in 3, 3 minus 2 is 1. 2 to the first is 2. Plus 1 is 3. And then if you plug in 4, 4 minus 2 is 2. 2 squared is 4. Plus 1 is 5. So go ahead and plot those and you'll get like a swoopy shape. And again, just make it go all the way to the edges of the grid. And then you want to label that one B on the left corner, the right corner, and in the middle. All right, so switch so that you have a third color. This is a little bit of an easier one to graph. What is this one going to look like? Linear, good. It's y equals mx plus b. So we're going to go down 3, put a point, and then our slope is 2. So up 2 over 1. And again, make it go all the way to the edges of the grid. And then you can label it C. All right, and then the last one, I'm really sorry. I meant for this to just be absolute value. That's not greatest integer. It's supposed to just be absolute value. Okay, I apologize. I'm sorry. It seems like you're all okay though. All right, so how did that one shift? Let's find the center. Left 1, good. Up 7. All right, so you're going to go left 1, up 7. And then because each side is linear, you can use that -2 as your slope on each side. Again, make it go all the way to the edges, and then you can label it D. Now it's going to take us a minute to do the next step of this here, so I'm going to pause the recording. So here's what we ended up with, and it is a flipbook for what's called a piecewise function. What we're going to do today is graph some piecewise functions, but this helps you really understand what a piecewise function is. What you can do is flip up like one section at a time. You probably had a book like this when you were a kid, or you've seen a book like this. I had one when I was a kid that was dinosaurs. Do you know how it's like the head of the dinosaur and then the body of the dinosaur and then the feet of the dinosaur, and you can mix and match them so that they're all kind of goofy? It's that, a head's nodding. Okay, cool. It's that exact same thing, except with math graphs. Okay, so you can kind of play around with it. And I'm just trying to like fold each section back at this point. But what we're going to write on our little half sheet of paper, I'm just trying to make a crease in all of these so this will be a little bit easier. So on your little half sheet of paper, I have a couple of questions here. It says, what is the domain for each section? Because when you have a piecewise function, the domain gets split or cut. And I think this illustrates it really, really nicely, which is why I like to make these. All right. What is the domain for the first section? This part right here, this portion. The domain for just this part. Negative infinity. I wanted you to think about it. Negative infinity until -1. Good. The domain for that first part is negative infinity to -1. Now, do we include the -1 or not? As long as you include it somewhere. So like if we don't include it here, we just do need to include it in the second part. Does that make sense? Like you have to include it somewhere. It doesn't matter which piece, but as long as it gets included somewhere. So we'll include it in the second piece. So the second piece of the function is domain from -1 until 3. And same thing with the 3. I'm going to include it here. And then in the third piece, we won't include it. You can't include it both places because then it wouldn't be a function. It would fail the vertical line test. So you can't include it both, but as long as it's one or the other. And then the third piece is 3 to infinity. So what we're going to do is just like have some fun flipping this. We're going to try to flip so that our graph is continuous at -1 and 3. Continuous means that the two pieces meet up. They link together. So can anyone find, and you can just say like A, B, C, D. Like the first section is B, second section is C, third section is D, whatever. But you want to try to find a way to get to link up at both sections. Can you try and find a way that that'll work? And don't say A. Some wise person always wants to say that every time, but you want to try and make them different and get it to match up. Can anyone find one? A, C, D? Oh, A, B, or A, C, D. Yeah, good. A, C, D. Can anyone find another one? C, A, D. Oh, I made my A and my D graphs too close to the same color. That's why it's nice if they're all four really different colors. I made them both, like this one's blue and that one's aqua, so you kind of can't tell. But yeah, C, A, D. All right, try and do one that's continuous at -1, but discontinuous at 3. Discontinuous means it won't link together. So find one that's continuous at -1, but discontinuous at 3. All right, let's do CAB. CAB. Or CAC. Not flipping this very long. Oh my gosh, the struggle is real. There we go. CAC. All right, can you find one that's discontinuous at -1 and continuous at 3? We want to be discontinuous at -1, but continuous at 3. What did you say? BCD? BCD is discontinuous, both of them, unless I misheard you. Oh, there we go. Got it. B as in boy. So BCB, BAD. There we go. What did you say? DCB. Oh, cool. Oh, that one looks neat. I like that. And then try and find one that's discontinuous both at -1 and 3. That would almost be like anything else, but yeah, like pretty much anything else. But do you guys remember those flip books that you had when you were a kid? They were like, mine was dinosaurs or clowns or whatever it was, and you could like mix and match them. That's like what this is, except for math. So I do think it's kind of cool. I realize I'm a math nerd, but when we do this, it helps everybody understand what a piecewise function is so much better. So when I hand you out the notes in a minute, it gives you a reference of like what it's supposed to be. So that's why I do like to go